Welcome back. Today we start with the most valuable skill in quant finance, the quant mindset. Most people think quant is about being smart with indicators or machine learning, but professionals know quant is mainly about process, a repeatable way to make decisions under uncertainty without fooling yourself. Here's what we will do in this lesson. We'll learn a research loop that turns a market idea into a strategy you can evaluate honestly. We'll learn how strategies really die, not from math, but from data mistakes, wrong timing, and hidden trading frictions. And I'll give you practical rules you can apply immediately, even if you are using Excel. Think of this lesson as building your quant operating system. Once you have it, every new idea becomes easier to test, improve, and compare. Quant investing has a real promise. Rules beat emotions. Rules stop you from panic selling, chasing hype, revenge trading, everything humans do when money is involved. But there's a trap. Backtests can lie. And the scary part is, they can lie while looking very scientific. A backtest is like a lab experiment. If your lab is contaminated, your results can look amazing. Let me list the three most common contaminations: bias and leakage. Your backtest accidentally uses future information. Overfitting. You tried many strategies and the winner is just luck. Unrealistic trading. No costs, wrong timing, assuming perfect fills. So today I want you to adopt a mental rule. A backtest is not a proof of alpha. A backtest is a tool to try to kill your hypothesis. If it survives honest tests, then we start respecting it. This is the quant research loop. Every professional workflow, whether at a hedge fund or a bank, can be simplified into these steps. Hypothesis. What do we believe and why? Data. Can we test it without cheating? Signal. Can we convert belief into a number? Backtest. What happens if we apply the rule historically with realism? Risk. Can it survive bad regimes? Execution. Can we actually trade it? Monitoring. How do we know it breaks? Each step is a gate. If you fail one gate, you don't move forward. And here's the big mindset shift. Quant research is not find a strategy. Quant research is build evidence and eliminate mistakes. Your edge is often not a magical signal. Your edge is the discipline of this loop. Now let's build hypotheses properly. Most people start with IHSG will go up, USD IDR will revert, rates will fall. That's not a hypothesis, that's a feeling. Use this professional template. If, condition, then action, over, because, economic reason. Example, if volatility expands and markets become trending, then trend following signals should perform better over the next 3 to 6 months. Because investor behavior creates persistent directional flows in stressful regimes. This is powerful because it forces clarity. What condition triggers the strategy? What is the action? What holding period are we targeting? Why should it exist as a risk premium or inefficiency? And you should always add one more line to your hypothesis. How could this fail? Because the best researchers design tests to break their own idea. This is the most important slide for real quant. I'm serious. Many strategies don't fail because the signal is wrong. They fail because the data pipeline is wrong. When you work with multi-geography data, Indonesia equities, US yields, DXY, commodities, you face three invisible problems: calendar mismatch, different holidays, trading days; time zone mismatch, different closes; missing values, gaps, staleness, non-trading days. Let's build the correct process step by step. Step 1. Decide your as of time. You must define what moment does each day represent. Example, end of day Jakarta time. Now, US assets will not always have a same day close value at that moment. That's okay. You use the latest available value as of that timestamp. This prevents accidental look ahead, especially when mixing New York close with Jakarta close. Step 2. Choose a calendar strategy. You have two valid approaches. Approach A, intersection calendar. Only keep dates where all assets have fresh observations. Pros, very clean statistics. Cons, you throw away lots of data, especially when mixing markets. Approach B, union calendar plus as of merge. Keep the main calendar, e.g., Indonesia trading days. And for other assets, you use the latest value available as of that day and time. Pros, realistic for portfolio valuation and daily monitoring. Cons, you must label and handle stale values correctly. For practical portfolio work, union plus as of merge is usually more realistic. Step 3. Missing values are not one thing. This is where beginners destroy accuracy. Missing values can mean market holiday, no trade. There is no new information. You can carry forward last price, but you must flag it as non-trading. Data gap, bad print. The data is broken. Forward fill here is dangerous because it fabricates stability. Better options, remove those dates, fix source, or resample to weekly. Stale prices, especially bonds and illiquid instruments, this is the killer. Flat price lines produce fake low volatility and fake high sharp. Step 4. Practical rules you can apply today. Here are rules I recommend. For FX and major indices, missing is rare. If it happens, treat as data error and investigate. For equities, if you're using index data, holidays are expected. Forward fill is okay with flags. For bonds, daily prices can be stale. Consider using yields instead, or resample weekly, or use vendor-verified pricing. A good default for many multi-asset strategies is convert everything into one currency, align into a single calendar, use as-of merge for foreign assets. Do not blindly fill true gaps. Resample lower frequency if liquidity is limited. Step 5. Mandatory sanity checks. Before you backtest anything, plot each series and visually scan for spikes and flatlines. Count missing by asset and by year. Compare volatility before versus after filling. If volatility collapses after filling, you created a stale price illusion. If you do this well, your backtest becomes trustworthy. And if you do this badly, nothing else matters. Now we turn an idea into a signal. A signal is not an indicator. A signal is a measurable belief that can be compared through time. A clean signal pipeline looks like this. Raw data, transform, signal, decision rule. Let's use a simple example, momentum. Raw data, monthly prices. Transform, compute 12-month return. Signal, that 12-month return number. Rule, if signal 0, allocate to risky asset. If signal 0, reduce risk or go to cash. 2 key teaching points. Signals must be defined before you look at results. Otherwise, you are designing after seeing the exam answers. Signals should be stable, not fragile. If changing a parameter slightly destroys performance, it's probably noise. When you teach quant, emphasize this. The signal is not the strategy. The strategy is signal plus risk plus execution. This is where most people are overconfident. They run a backtest and think the job is done. In reality, a backtest is only credible if you satisfy 3 minimum standards. Standard 1, correct timing, no look ahead. If your signal uses today's close, you cannot trade at today's close. You trade next bar. So you shift your signal by 1 period. This single rule eliminates a huge amount of fake alpha. Standard 2, honest costs and slippage. Include costs early, not later. If your strategy only works at 0 cost, it doesn't work. A practical teaching method. Run 3 cost scenarios: optimistic, low cost; realistic, mid cost; stress, high cost. If the strategy survives realistic and stress, now you respect it. Standard 3, out of sample evaluation. You must separate a period where you develop the idea, a period where you evaluate without changing rules. For time series, walk-forward testing is the most intuitive approach. You train on past, trade the next period, roll forward. And here's a key lesson for your audience. Backtesting is not about maximizing Sharpe. It's about understanding behavior across regimes and proving robustness. Overfitting is the most expensive mistake in quant. It's when you learn noise and call it alpha. Let me explain why it happens. Markets are noisy, and if you try enough models, one will look amazing by luck. This is not a moral failure, it's statistics. How to detect overfitting. Strategy performance collapses out of sample. Small parameter changes flip results. High turnover with tiny average edge. Performance concentrated in one short historical period. How to prevent overfitting. Teachable rules. Fewer degrees of freedom. Prefer 2 to 3 parameters over 20. Robustness tests. Shift start date, change rebalance frequency. Increase costs. Change look back slightly. Prefer economic logic. If you can't explain why it should exist, it's probably data mining. Avoid winner's curse. If you tried 100 strategies and choose the best, you must assume the best is inflated. A great line to teach. Robust beats brilliant, because brilliant often means curve fit. Risk is not volatility. Risk is what makes you stop trading or lose your career. In professional settings, risk management is not optional. It's the strategy's survival system. Teach risk in layers. Layer 1, drawdown control. Define a maximum drawdown threshold that triggers action. Reduce exposure, change regime mode, pause trading. Layer 2, volatility targeting. Instead of betting the same nominal amount, scale exposure so risk is stable. When volatility rises, position size decreases. This often improves survivability even if returns don't increase. Layer 3, concentration limits. Don't let one asset dominate your portfolio just because recent backtest shows it wins. Concentration is how portfolios die. Layer 4, liquidity/turnover constraints. If your strategy trades too often, costs eat alpha. So enforce a turnover cap or rebalance less frequently. Risk budget is the key concept. How much pain are you willing to accept for this expected return? If you can't answer that, you'll quit during the first bad regime. Execution is the bridge between research and reality. Many strategies are profitable on paper and untradeable in real life. Here are execution questions you must answer. When do you trade? Next day open? Next day close? Weekly? Monthly? Choose one, apply consistently. What costs are realistic? Bid-ask spread plus commissions plus slippage. For illiquid markets, slippage can dominate. How you control turnover? Turnover is a hidden tax. Even a small edge per trade disappears if you trade too frequently. What happens during stress? In crisis, spreads widen. Liquidity disappears. Correlations change. Now let's apply the process to something simple, an IHSG trend filter. I'm not presenting this as the best strategy. I'm using it as a teaching example of the quant mindset. Step-by-step application. Hypothesis. Trend filters may reduce drawdown during bear markets. Data. Ensure index series is consistent. Confirm timing. Confirm dividends if available. Signal. Moving average or 12-month momentum. Backtest. Monthly rebalancing. Signal shifted. Include costs. Risk. Max drawdown. Exposure caps. Execution. Monthly rebalance reduces turnover. What to teach from the results? Trend filters often protect during major downturns. They often lag in sideways markets. The performance depends heavily on costs and rebalance frequency. So the real takeaway is not trend is magic. The takeaway is a quant process lets you measure trade-offs honestly and choose a strategy that matches your risk budget. Let's close with what good quant looks like. Good quant is not complexity. Good quant is clarity plus honesty. A professional strategy has a testable hypothesis, clean, aligned, tradable data, a simple signal that you can explain, an honest backtest with timing and costs, a risk framework, an execution plan, monitoring rules for when it breaks. Now, your homework. Write a one-page strategy spec using the template. Do the data audit properly, especially calendar alignment and missing value rules. Define one failure mode. When should the strategy stop working? Next lesson, we go into returns, log returns, and compounding. Because if you compute returns wrong, your entire quant system is built on sand. Subscribe, and I'll see you in lesson 2.